Hello guys. Today we're doing lesson 9, more proofs with parallelograms but not on the coordinate plane. I'm doing this one on YouTube so I can go through more examples. The stream videos only allow me 15 minutes of recording times, which is why I sometimes get cut off. So we're going to use YouTube so I can take some time to go through more proofs and not have to rush through. So with every proof, we always start with the same thing. We start with our givens, so take the time to write that down. If you need to pause and go ahead. We're trying to prove that this shape ABCD is a rhombus. We're given that it's a rhombus. And we're trying to prove triangle ABC is congruent to triangle CDA. Now, if you know all your properties of a rhombus, then you have a lot of options of what you can do here. In a rhombus, because it is also a parallelogram, we have both pairs of opposite sides congruent, both pairs of opposite sides parallel, both pairs of opposite angles congruent. Because it's a rhombus, all sides are equal, diagonals are perpendicular, consecutive angles are supplementary, and diagonals bisect the angles. All sorts of different fun stuff that we can use. So you can approach this any way you want. So why don't you take a few minutes, try your proof, pause the video, and then come back and I'll show you what I did. Try it on your own, pause the video, try it on your own, then come back and I'll show you what I did. So a lot of options of what you can do. Whatever you decide to do, make sure you put an appropriate reason. So what I did is I said that because it's a rhombus, all sides are congruent. And then I used reflexive property for side AC. Now, you could have done all sides congruent and then opposite angles congruent and done side angle side. I did all sides congruent and reflexive property to get side, side, side. You also could have done the parallel lines and then alternate interior angles. So there's a lot of options of how you could use your rhombus properties to prove the two triangles congruent. As long as you say all sides of a rhombus congruent, opposite angles of a rhombus congruent, opposite sides of a rhombus parallel, make sure you say in your reason that because it's a rhombus, this statement is true. Okay, next proof. Here, we're given rectangle TURD, where M is the midpoint of TU, and we're trying to prove that MD is equal to MR, and then that angle MDR is congruent to angle MRD. So go ahead and write in your givens. You know what a midpoint is, so you can do your midpoint property. You know properties of a rectangle, so try to see if you can get some steps written in to help you get through this proof, or at least start it. So pause the video, go as far as you can go with this, and then come back and I'll show you what I did. All right, so I started out with saying TM is equal to MU because the midpoint creates two equal segments. If you said congruent, that's fine. If you use congruent, you would have to put the bar above the TM and the bar above the MU. So now that I know TM is congruent to MU, I'm going to start using some of my rectangle properties to get some other pieces of information. Now here's my goal. My goal is to get triangle TMD congruent to triangle MUR. If I can get those two triangles congruent, then by CPCTC, I will be able to get MD congruent to MR for the first part of what I was asked to prove. And then, if two sides of the same triangle are congruent, then the angles opposite those sides are congruent. That was the isosceles triangle theorem. That will get me the congruent angles that I need. So my focus is on these two triangles. All right. Right now I have the midpoints take care of one pair of congruent sides between those two triangles. Properties of a rectangle. I know that both pairs of opposite sides are equal, so that puts TD congruent to UR. Now I just need an angle in between those two sides, which works out conveniently that I have a rectangle. So that means that angle T is congruent to angle U. We know that all angles of a rectangle are right angles, so that means all angles of a rectangle are 90 degrees, which means all angles of a rectangle are equal in measure. So I should have a measure here and a measure there. When I use an equal sign, I need the M for measure of angle T equals the measure of angle U. The other option is to make them congruent, and then that works as well. All right, so that gives me side, angle, side. Then I can match up MD and MR by CP/CTC, and then the isosceles triangle theorem for those two angles that we were asked to prove. So pause the video, finish your proof, and then I'll see you at the next question. So once again, we got the triangles congruent by side, angle, side. We can match up MD and MR by CP/CTC. And then we can say the angles that we were asked to prove congruent because the isosceles triangle theorem. The isosceles triangle theorem says if two sides of the same triangle are congruent, then the angles opposite those sides are also congruent. So on to our next proof. All right, pause, fill in the givens, and then come back and we'll get started. Filling in the givens. Okay, so here's something that I want you to be careful of. There are a couple different parallelogram looking shapes in our diagram, and we are told that AMER is a parallelogram. So I want to highlight where our parallelogram is to start with. So this is our parallelogram here. We can use any of the properties of a parallelogram within this shape that I have highlighted in green now. We are trying to prove the triangles on each end that I did not shade in are congruent to each other. We were given angle 5 congruent to angle 4, and we're given that parallelogram in the middle. And we want to prove those two triangles congruent. So our options for proving triangles congruent, remember, hypotenuse leg, side, angle, angle, side, angle, side, angle, and side, side, side. So we're going to see what we can do with our parallelogram. Probably the most obvious first step is to say ME is congruent to RA because we know both pairs of opposite sides of a parallelogram are congruent. So that gives me already one pair of congruent sides, and I have one pair of congruent angles already. So we are in a good place in this proof. We just need to figure out a way to get a second pair of angles congruent, and then it's either angle, angle, side, or angle, side, angle, depending on where the angles are. So here's what I'm going to do. I'm going to explain it to you, and then I think what would be best is if you went and tried to do the steps on your own. I am going to be able to get angle 1 eventually congruent to angle 8. And the way I'm going to do that is use linear pair for angles 1 and 2, use linear pairs for angles 7 and 8, and then the congruent supplements theorem to get angle 1 congruent to angle 8. So if you know what I'm talking about, pause the video and try those steps yourself. Come back when you're done and I'll show you the steps. If you have no idea what I'm talking about, then I'll just hang on and I'll show you, but you should have an idea of what I've been talking about. Okay, so what I said was angle 1 and angle 2 are linear pairs, so that means they add up to 180. 7 and 8 are also linear pairs, so they also add up to 180. But mixed in with that, I also need angle 2 to be congruent to angle 7. I don't know what that is. So angle 2 is congruent to angle 7 because opposite angles of a parallelogram are congruent. So that gets angle 2 here congruent to angle 7 there. If you did your linear pairs first, that's fine, that doesn't matter. But I need 1 and 2 to be linear pairs, which means they're supplementary, and 7 and 8 to be supplementary as well. The reason why they are supplementary is because linear pairs are supplementary. I mentioned that a couple times. So there was a theorem that we proved and we've used a couple times. If two different angles, angle 1 and angle 8, are both supplementary to the same angle or to congruent angles, because angle 2 is congruent to angle 7, so angle 2 and 7 are equal, same measure. That means when 1 and 2 add up to 180 and 7 and 8 add up to 180, then 1 and 8 must be the same. That was called the congruent supplements theorem. So that gives us angle 1 congruent to angle 8, which then allows us to say the triangles are congruent by angle, side, angle. All right, wonderful, wonderful, wonderful. We're going to do a couple more. That's 1, 2, 3, and 12 minutes, 11 minutes. So we got 2 more to do. The next one's fill in the blank. This is an important one for us to do together because some of these might be a little trickier than what you're used to seeing, depending on how much of the practices you've done in the other units. Some of this might seem unfamiliar to you. If you've been doing the other practices and looking at the answer keys, then you probably might see some of these things that are familiar to you. But everybody's in a different place with where we're at, so we'll go through it. What I'd like you to do is pause the video, like I always ask you to do, and fill in as many blanks as you can, then come back and we'll check to see how you did. So pause the video, try it yourself, and then come back and I'll help you out with the ones that you weren't sure about. So make sure you read the given. Parallelogram ANDR. So we have a parallelogram. AW bisects DN. So segment AW bisects side DN. And then segment DE bisects side AR. Well, a bisector eventually is going to get us a couple of congruent parts. But because we have a parallelogram to start with, we know that AR is congruent to ND because opposite sides of a parallelogram are congruent. So that puts this whole side on the left congruent to that big side on the right. Now I have 1/2 of AR equals 1/2 of ND. In step number 2, we have AR equal to ND. Now I'm saying that 1/2 of AR equals 1/2 of ND. So I'm taking 2 segments that are equal and just multiplying each one by 1/2. That's the multiplication property of equality. So I'm taking 2 equal things and then multiplying them both by 1/2. So multiplication property of equality. Oops. All right, now I have 1/2 of AR equals ER. So if you look at the diagram, 1/2 of AR equals ER. And then 1/2 of ND equals WN. And how do we know that? Well, because it's a bisector. We are used to saying that the bisector creates 2 equal parts by saying AE equals ER. But 1/2 of a bisector is 1/2 the segment. So what we're doing is taking 1/2 the segment and naming it as ER. And then we can do substitution to get those 2 1/2 pieces congruent to each other. So that's a new way of using bisector for us. Nothing for you to get too stressed out about. Doesn't happen very often. But that's what they're looking for as to why 1/2 of the full side of the parallelogram is equal to ER. That's from the bisector. Next, angle ERD. If you look and find angle ERD and AND, or they have it labeled as WNA, those are opposite angles of a parallelogram. That's pretty straightforward if you remember where the parallelogram, or what the parallelogram is given. Sorry, I didn't say that right. That's an easy one to remember if you remember that there was a parallelogram given. All right, next. If you look at what we have so far, One thing that I didn't label from step number 2, we had both pairs of opposite sides of our parallelogram congruent, so I had another pair of sides congruent on the top and on the bottom. So now we have those two triangles congruent. Do you see why? Side, angle, side. So that would be our next step 7. Now we are on to step 8. Half of AR is congruent to AE, and half of ND is congruent to WD. That's the same thing as what we did up there in step 4. We're now just using the other halves, the other parts. And then AE equals WD would be substitution again. So let's label that AE equals WD. Now, if you were writing this on your own, you might have had a different approach to this, but that's one thing about the fill in the blanks that might make it difficult, is the person who actually put this together might have a different idea of how to solve the proof than you did. But you just got to go with what's there. And AE is parallel. Sorry, AE is parallel to WD. Why is AE parallel WD? Well, we were told at the very beginning that we had a parallelogram ANDR. So AE and WD are parts of the parallel sides. So opposite sides of the parallelogram are parallel from the big parallelogram. So parts of parallel segments are still parallel. So AE is parallel to WD. Now what we have is one pair of sides that's both parallel and congruent. So AE is parallel to WD, and we have AE congruent to WD. One pair of sides is both parallel and congruent. So that's that one all filled in. Now we're going to do one more proof together. This is a long one. So let's turn the page, get our givens written in, and then we'll go through this one, and then we'll be done for the, well, I'll be done for the day. You'll have a couple more to try on your own. And then we're testing very soon, so make sure you keep doing the practice. And let me know if you need anything with those practices. The answer keys are in our teams. All right, so we got the givens written in yet. We got parallelogram ABCD. They are telling us that AX is congruent to CY, which is also congruent to BC. So those are 3 pairs of congruent angles. And the parallelogram that they're giving us is ABCD. So that's the full big outer shape. So that one big giant parallelogram. And we're supposed to prove 2 things. That's why this proof is going to be so long. 2 things. ADX is congruent to CBY. That's the 2 triangles at each end. And then prove that AXCY in the middle there is also a parallelogram. So I have a parallelogram inside the parallelogram. So let's focus on our triangles first. What we have is a parallelogram ABCD, so we can use any of those properties for the parallelogram from ABCD to help us with the little triangles. So why don't you pause the video and see what you can come up with for trying to prove ADX congruent to BCY, and then come back and we'll see what I did. We'll compare. So the first thing I did was kind of take the obvious route that BC is congruent to AD because opposite sides of the parallelogram are congruent. That gives me another pair of sides. That one. That one. And then I also put angle D is congruent to angle B because opposite angles of a parallelogram are congruent. So that gives me that as well. And then knowing what I know about, knowing what I know about triangles, angle D is congruent to AXD, and angle B is congruent to BYC. So if angle Y is congruent, if side YC is congruent to side BC, that means this is an isosceles triangle. If 2 angles of a triangle are congruent, then, if two sides of a triangle are congruent, then the opposite angles of that triangle are also congruent. So that's the isosceles triangle theorem. So what we have, just to make sure we're clear with what's happening here, we were given that AX is congruent to CY, which is congruent to BC, and then we proved that BC is congruent to AD. That means all four of those segments are congruent to each other, making an isosceles triangle on each end. So AD is congruent to AX, so isosceles triangle theorem gets the base angles congruent. And then BC is congruent to YC, so isosceles triangle theorem again gets the base angles congruent. So that's why I get those triangles congruent, or those angles congruent, AXD congruent to D and BYC congruent to B. Now, since we have AXD congruent to D, and D is congruent to B, with angle B congruent to BYC, that means AXD is congruent to BYC. That could be substitution. If you remember correctly, that is also the transitive property, where if two different items are equal to the same value, then they have to be equal to each other. That was the transitive property. But it might be easier for you guys just to understand that it's a substitution with angle D and angle B turning into AXD and BYC. All right, so the reason why I needed to do that is because before getting those angles together, the information I had for the triangles was angle side side. We cannot use angle side side. It spells a bad word, and we do not use that in geometry. So angle side side doesn't work. I needed another piece. I was able to get another angle, which then allows me to say the triangles are congruent by angle angle side. So that's the first part of our proof all taken care of now. The next issue is to prove that AXCY is a parallelogram. So we can go back to the fact that we have a big parallelogram on the outside to say AB is parallel to DC because we know opposite angles of a parallelogram are parallel. And if those opposite angles are parallel, then we can get some alternate interior angles. My goal is to prove that the parallelogram shape on the inside of the bigger parallelogram, so AXCY, I'm trying to prove that is a parallelogram. So that means either both pairs of opposite sides parallel, both pairs of opposite sides congruent, one pair of opposite sides both parallel and congruent. You know, we have some options. So we have the triangles are ready. I know that the bigger shape is a parallelogram, so now I have a pair of parallel sides. That pair of parallel sides is going to allow me to say angle BYC is congruent to angle YCX, and angle AX, that's this one here, congruent to that one, and then angle YAX here congruent to AXD here. Now we have the angles inside the triangle already congruent. Now they are congruent to some angles that are inside our parallelogram. So that means if I use substitution or the transitive property again, similar to what I did in step 5, that'll give me a pair of opposite angles inside the parallelogram that are congruent. So that's one pair of opposite angles congruent inside my parallelogram. So now, if I can set my attention to the other pair of opposite angles, so if I need to get AYC congruent to AXC, then I'll have both pairs of opposite angles congruent, and therefore it's a parallelogram. So if you know what to do, similar to the last proof, or 2 proofs ago, with the linear pairs and the congruent supplements theorem, then you should be able to finish this proof on your own. So pause it, go ahead and do it. If you need my help, hang on, and I'll be right there. So what I'm going to do is the same thing that I did back in proof number 3. So I'm going to use linear pairs to say angle BYC is supplementary to AYC. And then similar in the other corner, AXC is supplementary to DXA because linear pairs are supplementary. And then I can use congruent supplements theorem to get the opposite angles congruent, and then I have a parallelogram because both pairs of opposite angles are congruent. Angles, Mr. Stewart, angles. And there's proof number 5. So we just did 5 proofs in 25 minutes. And I went slow. So there's 6, 7, 8, 3 proofs left on this practice. So give them a shot. You have access to the answer keys as you need. And you can contact me if you need more assistance. But some of you I will see tomorrow. Some of you I will see Monday on test day. So good luck, guys. Stay safe and be well.